we're looking at the division algorithm for polynomials. Let's look at an example and do a little bit of analysis. So let's say I've got x cubed plus 4x squared minus 2x plus 5, and I want to divide that by x plus 1. Now, before we go ahead and do that, let's just sort of consider an example with numbers and just get the general idea about how all this works. So if I go 32 divided by 4, essentially what I'm saying here is I want to find, I've got 44 times something is equal to 32. And if I say I can't quite work out what the number is to get up to 32, but I do know that 4 times 5 is equal to 20, I basically sort of used up 20 out of the 32 and 12 is left. And so I go kind of 4 times something is equal to 12, and I can work out there's a 3 there. So sort of looking backwards, I've got 5 lots of 4 gives 20 and 3 lots of 4 gives 12. So 5 plus 3 is equal to 8, and so 4 lots of 8 will be 32. The division algorithm for the polynomials works in exactly the same way. So if I take my example, what I want to work out is I've got x plus 1 times something is equal to x cubed plus 4x squared minus 2x plus 5. Now I know that I must have as a result of this multiplication, I've got to end up with an x cubed. So in here there must be an x squared. And I know that if I expand x squared against the x plus 1, I will get x cubed plus x squared. So essentially I can now subtract that, and what I've got left is 3x squared minus 2x plus 5. That's like my leftover. And then I can ask myself the same question. X plus 1 times what is equal to 3x squared minus 2x plus 5. Again, I've got to get a 3x squared, so there must be a plus 3x sitting in here. So then I can, again, if I've got a positive 3x and it's going to expand, it's going to be multiplied against the x plus 1, I'm going to get a 3x squared, and I'm going to get a plus 3x. So I can now take that out, and I end up with minus, just getting a better line, basically minus 5x plus 5. So again, I've got x plus 1 times what is equal to minus 5x plus 5. Best I can do is minus 5. And that's going to be minus 5x minus 5. And if I take that out, unfortunately, I haven't done too well here because I've got a leftover of 10. So I know that that x cubed plus 4x squared minus 2x plus 5 is going to equal x plus 1 times x squared 3x minus 5, x squared plus 3x minus 5, with a leftover of 10. If I now just do the algorithm, it's just going to follow. It's going to follow exactly that process, but it's just essentially the only difference is the way that it's laid out. And so I now write it like this. And again, I ask myself all the same questions. So x times what gives x cubed? It's going to be x squared. I multiply that by x plus 1, so that gives me x cubed plus x squared. I take it out, so let's give me 3x squared. I could bring down all of this on the right here, but I'm only going to be working 2 terms at a time, so to speak. So I'm just going to bring down the minus 2x. So that's going to give me my plus 3x, and that's going to give 3x squared plus 3x. And that's going to give me, take that out and I get minus 5x plus 5, and I get my minus 5 minus 5x minus 5 positive 10. And obviously, so I'm just getting exactly the same thing will come out as I've just done. Just doing a couple of other quick examples just to sort of show a couple of things, and many of the more regular things will just happen when we do solving cubics in the next chapter, so to speak. Let's just look at a fun example. If I've got x cubed minus 1 divided by x minus 1, like that. The main reason I'm doing this is that I've got an x cubed and then it goes straight down to minus 1. If I'm setting up this algorithm, I need to sort of consider, if you like, for want of a better way of putting it, all the place values in the polynomial. So it's x cubed plus 0x squared plus 0x minus 1. Almost like, you know, ones, I mean, basically almost like the place values in numbers. So again, I'm just going to go through. So I need to get x cubed. So my first part of my quotient up here is going to be x squared. That's going to give me x cubed minus x squared. And then I get 0x squared minus x squared gives me positive x squared, and I'll bring down that 0x. So my next one's going to be positive x, and that gives me x squared minus x, positive x minus 1, and that gives me a positive 1. So x cubed minus 1 is going to equal x minus 1 x squared plus x plus 1. Just doing again one other one. Let's look at, if I can find it quickly. Damn it, sorry, readjustment happening here. And we'll look at x cubed minus 7x squared plus 3, and we'll divide that by x squared plus 2x plus 1. Now in this case, setting it all up, I must put in the kind of missing place value, so the plus x there, plus a 0x, plus 3 like that. And again, I'm not going to get very much up here because I'm already up to an x squared here. So my first multiplier is going to be x. That's going to be x cubed plus 2x squared plus x. Subtract, that gives me minus 9x squared minus x. And that gives me a plus 3 at the end. My next number is going to be minus 9, and that gives me minus 9x squared minus 18x minus 9. And if I subtract this, I now get 17x plus 12. And so just the interesting thing in this case is that I get a remainder that has essentially has an x term to the power of 1. And so x cubed minus 7x squared plus 3 is going to equal x squared plus 2x plus 1 times x minus 9 plus 17x plus 12. And more of those just to be done in the next chapter.